Today I'm going to be explaining the physics of basketball with the concept of hang time. Jumping is a major component in physics behind basketball. When a basketball player jumps in the air to make a shot, he can appear to be suspended in midair during the high point of the shot. This is a consequence of projectile motion. In this video, you see me jump up and my hang time when I dunk the ball. In this image, you can see almost half the hang time is spent in the top of the arc. Using some mathematics, one can calculate the time spent in the top part of the jump. Using this formula, you could see the linear motion with concept acceleration. D equals V1 time minus 0.5 grams time squared. Where D is the vertical jump distance, V1 is the vertical component of jump velocity at takeoff, and T is time. G is the acceleration due to gravity, which is always 9.8 millimeters per second squared. The maximum jump height is reached at T equals V1 divided by G. Using the formula above for D, the maximum height reached is D max equals V1 squared divided by 2G. Now to calculate the following ratio, it would be D half divided by D max, which equals 0.75. The interesting result tells us that half the hang time is spent in the bottom 75% of the jump. The remaining time is spent in the top of the jump, the top 25% of the jump. In other words, half the jump time is spent in the highest 25% of the jump. This explains why basketball players have to hang during the jump. So a player who can jump 4 feet vertically will have a hang time of around a second, with a half a second spent in the high part of the jump. Obviously, a person can't remain airborne for long. Why, you ask? Well, Newton's most beloved law, gravity, comes into play. The gravitational force on Earth begins pulling you back down as soon as your feet leave the ground, despite your desire to go as high as you want. Earth pulls you back to the ground with an acceleration of 9.81 meters per second squared, like I said previously. In this video, you can see me jump very high, but gravity is trying to pull me down. In the slow-mo video, you see it broken down in a slow pace. You see my legs push back and bearing all my strength forward to bring me as far and high as I can to bring the best hang time. Here is me. This is me jumping. At here is when I hit the maximum height of my arc. And then this is where I finish, which is the X. Gravity is pulling me down at 9.81 meters per second squared. Now here we have a vertical direction and a horizontal direction. So as you can see, the highest point is where I'm the tallest in the air, and this is the lowest. Thank you for watching, Miss Krebs.